The following problems are from the Roman numeral 3 section of your notes on rotary motion. They should help you do some of the Chapter 8 homework problems as well as help you prepare for the test. First question, a wheel is rotated so that a point on the edge moves through 1.3 meters. That would be your distance. The radius of the wheel is 2.7 meters. Through what angle in radians is the wheel rotated? Our formula is going to be D equals R theta. When we plug in our numbers, we're going to have 1.3 meters equals 2.7 meters times theta. Simply divide on both sides by 2.7 meters. Notice that your units will cancel, and when you type that into your calculator, you should get an angle of 0.48 radians. Question 2. The outer edge of a tire has a radius of 42 centimeters. Remember, all lengths should be in meters, so we're going to convert that and move the decimal 2 places to the left, so we now have a radius of 0.42 meters. The velocity given is 23 meters per second. You are asked to find the angular velocity, which is omega, it's the curvy W, and our formula is V equals R omega. We can plug our numbers in. Don't forget, you've changed the radius to 0.42 meters. On the left for velocity, we're going to plug in 23. That's equal to 0.42 times omega. When we divide, you get an angular velocity of 54.76. The meters on both sides have canceled out, but we're left with radians on top and seconds on the bottom. When we say 196.7, next question. A propeller spins at 31.3 revolutions per second. This is something new. Whenever you see something per second for revolutions, that is going to be a frequency. For part A, when you're asked to find the angular velocity, that would be omega. This would be an example of a bonus question using frequency. If you look in that section of the notes, when we did angular velocity, one version you could use to find it would be 2 pi times the frequency. So in this case, all you have to do is plug in 2 pi times 31.3. And if we type that on our calculator, you can do 2 times 3.14, or you can do 2 times the pi button, multiply by 31.3 revolutions per second, and you get an angular velocity of 196.7 radians per second. Remember, something like part A would be a bonus question. Part B, when you're asked to find the angular displacement, that would be theta, and you are given a time of 1.75 seconds. This version of angular velocity was one of the ones that was required, and the formula looked like this. Angular velocity is equal to angular displacement over time. So when we go to plug in our numbers, we found the angular velocity in part A, and angular displacement's what we're looking for, and you were given a time of 1.75 seconds. We're simply going to multiply the time on both sides, so when we say 196 times 1.75, you get an angular velocity of 344.2, and that's radians per second. So part A would be a question like a bonus. Okay. Part B is something that would be required. In this case, I would have given you angular velocity and asked you to find angular displacement. Next question. You've got an angular velocity slowing down, so it's negative, and a time of 4 seconds. You're asked to find angular acceleration, which is the alpha symbol. Since you aren't given any other value for a change for your omega, the angular velocity, you simply plug in the negative 30 radians per second and divide by the 4 seconds that were given. So we're going to have negative 30 divided by 4. And you should get negative 7.5 radians per second squared. The outer edge of a tire has a radius of 35 centimeters. But wait, what do? You can't have centimeters. You need to convert to meters. Move your decimal. You now have a radius of 0.35 meters. We're given a velocity of 22 meters per second, and we're looking for angular velocity, which is the omega. Our formula to find this, V equals R omega, we're going to plug in 22 for the velocity, 0.35 because we convert to meters for the radius, and then omega. So 22 divided by 0.35, we get an angular velocity of 62.9 radians per second. Next, a car has a linear acceleration. Linear just means in a straight line. That's the normal acceleration that we had back in Chapter 3. It's 1.7 meters per second squared. You're given the radius of a tire of 0.35 meters. It's already in meters, so you don't have to do any conversion. And we're looking for the angular acceleration, which is the alpha. So in order to find this, our formula is going to be linear or regular acceleration is equal to radius times alpha. So we're going to plug in 1.7 meters per second squared on the left, 0.35 meters times alpha on the right. We're going to divide by 0.35 meters on both sides. When we do that, the meters section is going to cancel, and that's going to leave us with units of radians on top divided by second squared, and your number when you divide 1.7 over 0.35 should be about 4.9, and that's equal to angular acceleration. Two more. We have an outer edge of a tractor tire, radius 82 centimeters. What do? Good. I know you said that out loud while you're working at home in your room. Okay, so move the decimal 2 places, so radius of 0.82 meters. Velocity is 18 meters per second. Part A, we're looking for angular velocity. We've had this formula a few times already in the review, so we're going to plug in 18 is equal to 0.82 times our omega, and when you divide, you get an angular velocity of 21.95 radians per second. Part B, you're given a time, 0.963 seconds, and you're asked to find angular displacement. That's going to be the theta version. Our formula that uses all of those things looks like this. Angular velocity, which is the omega, equals angular displacement over time. So I'm going to go ahead and rearrange that and multiply time on both sides. So we get angular displacement is equal to angular velocity times time. We're plugging in our number from part A for angular velocity, and then the 0.963 seconds that you were given for the time in the problem. So 21.95 times 0.963 gives us an angular displacement of 21.1 radians. Our last question. Rotary engine starts at rest, and then it's going to undergo a uniform angular acceleration of 3.9 radians per second squared. Remember, angular just means spinning. And we started at rest, so we had an angular so 21.5 meters per second equals the radius, and then we're using our answer from part A of 54.6 radians per second. And when we divide both sides by the angular velocity, the units are going to cancel out and leave us with just meters. So we're going to have 21.5 divided by 54.6, and we get a radius of approximately 0.39 meters. So you'll have questions similar to these on your test as well.